A traffic safety company publishes reports about motorcycle fatalities. In the first accompanying data table, the distribution shows the proportion of fatalities by location of injury for motorcycle accidents. The second shows the location of injury and fatalities for 2,073 riders not wearing a helmet. And what we're trying to figure out is whether the distribution for fatal injuries of riders not wearing a helmet follows the distribution for all riders. So here, this 2,073, this is for people not wearing a helmet. And so we're trying, we know this is a goodness of fit problem because we're trying to see how well this data fits with the data up here. So we're going to do a goodness of fit. StatCrunch. So I have these written down in my notes what to do, but so let's say you didn't have it written down. So you would go over here to the StatCrunch guide and say goodness of fit test. So there's this observed counts and expected counts. Okay, so the probability in the population that somebody would have a fatality from having injuries in multiple locations is 0.57. That's 57%. And so what we have to try and do is we have to try and figure out what the expected count is. And the expected count is so I have a formula for that in my notes, and the expected count is the number times the p, the probability. And so we could do that count over here. I haven't done these calculations since the very beginning of the semester now. Compute expression. So we're going to do probability times frequency. Okay. Oh, actually, that's not right. This is what a lot of people do wrong when they do this problem. It's actually, we need the probability times n is the total number of people in our sample, which is 2,073 people. And what we're trying to figure out is if our expected counts match this, what these counts are here. And so 2,073 is what we want to do here. And these are expected. So these are expected and these are observed. And what we're trying to figure out is how well these two fit with each other. And that's what the question is asking. And that's what a goodness of fit test does. And so does the distribution follow the distribution for all riders? Use a level of significance of 0.1. When we do that, we go chi-squared stat, goodness of fit, chi-square test. And so our observed column is our frequency, and our expected column is expected, and compute. So basically with the goodness of fit, the null is that they match, and the alternate is that they don't match. And so that's what this test does, and that's what we're trying to look for. And then here, so the expected counts, again, you're not using the observed counts, you're using the probability numbers and the 2,073 to get your expected counts.
So essentially you're just multiplying the proportion by the number of riders.
Yes. Yeah. So if we go look again at the table, and this is actually confusing, especially when it shows up in StatCrunch. There's this urge to just multiply these two together. And you got to resist the urge because we're trying to figure out if 57% of the fatal injuries was from multiple locations, how many riders would that be? Would we expect it to be if there were 2,073 riders? So that's why we multiply the 2,073 by each of these decimals, because we're saying that's what we expect it to be. But then these are the actual numbers that we have, and we're trying to figure out how close together these two things are. And so then the p-value of the test was what I found here. So the p-value is much less than, it's less than 0.0001. It says round to 3 decimal places, so that's just 0.000. That's how you figure this one out. So these numbers should be pretty close. Observed and expected should be kind of the same kind of numbers. So if you're not getting things that are similar numbers, then that's kind of a clue that maybe you're not doing something right, because the expected is what we're trying to compare these two and see how similar they are.